When we start getting into hypertrophy programs, it will be important that you understand how they are designed and why they work. It's imperative that you grasp each method as we cover it. The first method we are going to discuss is mechanical tension. When you flex a muscle, you create tension within it, and the harder you flex it, the more tension you create. So when you pick up a 20-pound dumbbell, you create enough tension to lift 20 pounds. When you increase the weight from 20 pounds to 50 pounds, the amount of tension needed to move the weight also increases. The amount of tension we create is directly related to the amount of force we need to apply. This brings us back to our understanding of motor units. Remember that motor units innervate with every muscle fiber. Therefore, the more motor units we engage, the more muscle fibers we work. Here's a simple way of looking at it. Let's assume we have a heavy car we need to move. One person isn't strong enough to move it, so we recruit another. If we still cannot move it, then we recruit yet another person. We continue recruiting until we have enough people to move the car. This is also how motor units work. You keep recruiting muscle fibers until you have enough to perform the task. Now, this next bit is very important. Muscle fibers are recruited in a hierarchical pattern, smallest and weakest to the largest and strongest. When trying to move a load, you only engage what's required to move it. So if you have 5 people and only require 3 to move the car, then only 3 out of the 5 will do the work. The same goes for muscle fibers. You only recruit what you need. So in this example, you are potentially leaving out your 2 biggest muscle fibers. Those large muscle fibers have the most growth potential, which is why recruiting them is so important. There are 3 ways we can maximize motor unit recruitment. The first, similar to the example just given, is the load. The second is velocity, and the third is the mind-muscle connection. First, let's deepen our understanding of load. When we refer to our 1 rep max, we are talking about the maximum load we can lift for 1 rep, which equates to a 100% effort. A 100% effort means we are using everything available to us to move the given weight. So, when we are lifting a load that is 80% of our 1 rep max, we only recruit the muscle fibers necessary to move that specific amount of weight. So we know that the heavier the load is, the more motor units we will be recruiting. Another variable that we can manipulate to increase motor unit recruitment is velocity. Velocity is the speed from one position to another and is measured by mass times acceleration. So, how fast you moved the weight from the bottom start position of a bicep curl to the top finished position. Our focus is going to be on increasing acceleration to increase velocity. Let's assume we're doing a bicep curl. If we have a load that is 80% of our 1 rep max and curl the weight with an 80% effort, we may only recruit around 80% of our muscle fibers. In this example, we are using effort as a gauge for how fast you are trying to move the weight. Now let's assume we have the same weight, but we are going to give a 100% effort towards moving the weight as fast as possible during the bicep curl. In order to accelerate the load as fast as possible, your body must recruit more motor units. Therefore, to move the same 80% of your 1 rep max as fast as possible, your body could recruit 100% of its muscle fibers. Recall this image from earlier? We only needed a limited number of people to move the car. But what if we wanted to have it move quickly right from the start? We can't make the car lighter, so the only option is to push harder and generate more force. Since each individual is already maxed out, we recruit more people to push the car. This is exactly how your body works to increase the velocity of an exercise. Now, the weight itself doesn't need to literally move fast. The simple intent of accelerating as fast as possible increases motor unit recruitment. The third variable towards maximizing motor unit recruitment is your mind-muscle connection. Here is a charted EMG of two muscle contractions. The same load and velocity was used in both contractions. The only difference was the mindful intention of flexing and working the muscle as hard as possible. The concept of mind-muscle connection means you are activating a muscle and not just moving a weight. You want to perform a conscious and deliberate muscle contraction of the intended working muscle. You should be able to feel it working and contracting hard. It can be very hard to build up a mind-muscle connection with some muscle groups, so it requires patience and persistence. Now, we're going to dig into what's so magical about mechanical tension and why it's possibly the most important factor in muscle hypertrophy. The hypertrophic response can vary based on the type of muscle action. There are three specific actions a muscle can perform. 1. A muscle contraction. 2. An isometric contraction. And 3. An eccentric contraction. What's unique about eccentrics and isometric contractions is that both have been shown to generate hypertrophy by vastly increasing mTOR. mTOR is a kinase enzyme that links with other proteins to regulate cell function. mTOR is unique in that it governs cell growth, which is the goal of hypertrophy training. Mechanical tension is also key for long-term results. Often when people reach a hypertrophy plateau, it's because they are underutilizing mechanical tension. It's important to note that you only have 10 to 15 seconds where you have maximum recruitment. Those giant fast twitch cells that predominantly run on ATP and creatine phosphate burn out quickly. So it's important that you optimize that window. By training with greater loads, you can see a greater increase in strength. With more strength comes more motor units, which long term leads to greater hypertrophy and breaking through plateaus. Recall this slide from earlier? It's displaying how 80% of your 1 rep max recruits 80% of your motor units. It actually looks a little more like this. Notice how the biggest, most powerful muscle fibers aren't even being recruited? If we can increase motor unit recruitment and tap into those motor units, we can chase an even greater hypertrophy response. This is what it can look like when you increase your strength and engage more motor units. In this example, the opportunity for hypertrophy is clearly much greater. And the final piece is understanding the length-tension relationship. Every muscle has an ideal length which can increase the force generated for a muscle contraction. If you take a look at the chart, it shows you how muscle tension, the vertical axis, increases as the muscle length, the horizontal axis, increases. The purple line shows decreasing contractile strength as the muscle lengthens. However, the green line shows an increase in passive tension as the muscle lengthens. The sum of both tensions produces a greater overall tension and opportunity to generate force. Let's take a look at how passive tension contributes to potential force production. Take your bicep, for example. For the sake of keeping this simple, imagine it has a given length from the top of your humerus to the base. When we remove your bicep from your arm, it actually shrinks and reduces in length. This occurs because it is partially stretched like an elastic band between the points of origin and insertion. This is defined as the length-tension relationship and what allows greater force production from a fully lengthened position. The key takeaways of mechanical tension are: mechanical tension may be the most important factor in exercise-induced hypertrophy because of its impact on mTOR. Maximize motor unit recruitment to maximize tension and build muscle over the long haul. And favor a full range of motion to maximize the length-tension relationship.